Hey everyone! Now, I will tell you about sequence and series in mathematics for senior high school. Before that, I will introduce myself. My name is Gede Wisnu Budipratama from Mathematics Education on Ganesha Education University with student ID number 211-3011-019 class 4C. In this video, we will talk about four main topics, which is definition of sequence, definition of series, some type of sequence and series, and the last is arithmetic and geometric progression. First, I will explain the definition of sequence. That sequence is a set of numbers written in specific order. For example, 1, 3, 5, 7, 9, etc. Those are the type of sequence that we will often encounter. As for some other type of sequence, such as on the slide, there are sequence 1, 4, 9, 16, 25, etc. The next type of sequence square number as seen on the slide. Next, we will talk about a finite sequence. As seen on the slide, if we have sequence 1, 3, 5, and 9, the sequence will be named finite sequence contain 4 numbers. On the other hand, a finite sequence can be described such as 1, 4, 7, 10, 30 until n. In this example, the element n indicate this order is a finite order because n is its last element or term from this sequence. Now, we will discuss the structure in their order. Suppose the sequence of 1, 5, 9, 30, 70, etc. We will call the first one term in this order or in this formula, it is U1. Similarly, 5 is the second term that will be called U2, U2, and so on. We will write UN to represent the n term in their sequence. In math formula, we will write U1, U2, U3 until UN. For example, we will use this notation to describe the rule for the sequence of Fibonacci, which is UN minus 1 added with UN minus 2. This notation say to find UN in Fibonacci sequence, we must add the two preceding terms. Okay, now we will discuss the next topic, which is series. A series defined is something we derive from a sequence by adding all the terms together. Let's say we have a sequence U1, U2, U3 until UN. The series we get from the sequence is U1 added U2, added U3, added U4 until UN. And the notation for this series is Sn. The number of terms 1 through n. For example, the series as already seen on the slide. Sequence and series are interconnected with each other. However, sequence and series have some basic difference, such as sequence use comment and series use plus C. In sequence, order of the element is important, but in series is not so important. And the last, from definition, we can get sequence is a set of the element follow a pattern, and series is a sum of an element from a sequence. Okay, I think there has been quite a discussion about the definition of sequence and series. Now, we will discuss the type of series and sequence. In this video, we will discuss 4 types of sequence and series, such as arithmetic sequence, geometric sequence, harmonic sequence, and Fibonacci sequence. First, the arithmetic sequence. Arithmetic sequence is a sequence in which every term is created by adding or subtracting an exact number to the previous number. Formulas and example for this type we will discuss more fully after this topic. Okay, second one is geometric sequence. Geometric sequence is a sequence in which every term is obtained by multiplying or dividing a definite number with the preceding number. Such as arithmetic sequence, formula and example for this type we'll discuss more fully after we clear this topic. For the third type is harmonic sequence. A series of numbers is said to be in harmonic sequence if the reciprocals of all the elements of the sequence from an arithmetic sequence. For example, 1/3, 170, 111, 150, etc. We'll call harmonic sequence because 3, 7, 11, 50, etc. called arithmetic sequence. For the last step is Fibonacci sequence. The Fibonacci sequence is one of the most famous sequences. This sequence has another name, namely golden ratio. The golden ratio is often used in the field of art and graphic design because this sequence can add aesthetic value to artwork. Each element from Fibonacci sequence is obtained by adding two preceding elements, and this sequence will start from 0 and 1 from the first and second element. Fibonacci sequence is defined as f0 equal 0, f1 equal 1, and for fn equal fn minus 1 plus fn minus 2. Okay, for the next material is arithmetic progression. In this topic, we will discuss about formula we will use for arithmetic sequence and series. In arithmetic progression, first term in sequence or series will call it by A. Element location for arithmetic or geometric progression will write by UN, which is N is the position for the element in sequence or series. And the last we have D, obtained by subtraction UN by UN minus 1. For all the preceding notation, the formula is obtained for the arithmetic sequence that UN equal to A added by the product of D with subtraction of N by 1. And for an arithmetic series is Sn equal to n divided by 2 multiplied by the sum of the result of A by Un. Okay, for the last topic we will discuss is geometric progression. In geometric progression, notation we will use similar like arithmetic progression. But in geometric progression, we not use D. We have R, meaning to ratio. We can obtain R by dividing UN by UN minus 1. The formula for geometric sequence is UN equal to multiplied by n r power n. And the formula for geometric sequence is dividing into two parts based on ratio we get, as seen on the slide. Okay, that's all for the material we discussed in this video. Stay tuned for the next video as we will cover more other math concept, especially for senior high school. Okay, thanks for all and goodbye.